കഴിഞ്ഞ ക്ലാസ്സിൽ ഡിസ്കസ് ചെയ്തത് ഫിബോനാക്കി സീരീസ് പ്രോബ്ലം ആണ്. ഓക്കെ, അപ്പോൾ then how we can do the divide and conquer Fibonacci series problem. Okay, this is Fibonacci series problem, and this is also important. Sometimes in the university exam they may ask question like perform divide and find the nth Fibonacci number using divide and conquer approach and dynamic programming approach. Sometimes in the exam they may ask such type of questions. Okay, so this is also very important. So I am discussing this at first. Okay, then we will discuss a Bellman Ford algorithm. This already discussed. Okay, so these are the last topics. Fibonacci series, you know what is a Fibonacci series. Okay, already you know what is a Fibonacci series. This is Fibonacci series. Fib of 0 is 0, fib of 1 is 1, fib of 2, what is fib of 2? Fib of 0 plus fib of 1. What is fib of 2? Sorry, what is fib of 3? It is this plus this. What is fib of 4? This is this plus this. Okay, in this way the series will proceed. Okay, so this is Fibonacci series. Then we want to find the program to find nth Fibonacci number. Okay, we want to find the nth Fibonacci number. Okay, so this is the algorithm for finding the nth Fibonacci number. Nth Fibonacci number. So the concept is very simple. If n less than or equal to 1, okay, then return n itself. Okay, for example, I want to find the first Fibonacci number. Then it will check 1 less than or equal to 1, then return 1. Okay, these two cases. Okay, these two cases. Okay. Then that is the base case, or I can write in this way. If n equal to 0, return 0. If n equal to 1, return 1. Then if n greater than 1, then what we want to do? We want to call this Fibonacci function two times. Okay, one is with the fib of n minus 2 and another is with the fib of n minus 1 after I want to perform the addition. Okay, so this is the general case. So this is the general case. Okay, and this is the recursive function. Okay, next I'm discussing this example. Find the fifth Fibonacci number. Okay, please just write it because this is a tutorial hour, so just write it. Okay, fib of 5. Okay, so I want the fib of 5. Okay, how can find it? Okay, how can find it? Initially it is called with this function. Fib is called with 5. Okay, it is called with 5. Then what will happen? Then what will happen? Fib is called with 5. Then this function, that is this function is called with 5. Okay, 5 less than or equal to 1? No. So it will execute this part. Okay, it will again call the fib with the fib of n minus 2, fib of n minus 1. Okay, so that is it will call in this way. It will call this one and this one. Okay, so next which function of this will execute? This will be executed. Okay, fib of 3 will be executed. So what it will do? It will again check 3 less than or equal to 1? No. So it will call this one. Okay, fib of 1, fib of 1, fib of 2. It will call this also. Then this get executed. So this is a base case. So fib of 1. What is fib of 1? If fib of 1, then what we want to do? We reached at the base case. This is the base case. That is 1 less than or equal to 1. Then we want to return 1. Okay, so we returned 1. Where I will return the value? I will return where? To the parent. Okay, so it is returned 1. to here. Okay, then it will call, then it will execute this path. Okay, from this path will execute. Then the control reaches here. Then 2 less than or equal to 1? No. So it will again make 2 calls. Okay. So it will again make 2 calls. Then one is fib of 0. This at first executed. Then what it will do? What is fib of 0 is 0. So it will return 0. Okay. It will return 0 to here. Then control reaches back here. Then it will call this function fib of 1. Okay. This function. It will call fib of 1. Okay, so this is base case is reached here. Then it will return 1. Okay, it will return 1. It will return 1. Okay, so these two are completed. Then what it will do? What this function will do? This function will sum this 0 plus 1, 1 and return back. Okay, so what will happen? It will return 0 plus 1, 2 to its parent, 2 to its parent. Okay, so what it will do? Okay. So the working of a recursion tree is very important. Okay, and that's why I'm repeating this working. So it will reach us here. Then what it will do? It will perform 1 plus 2. Now 3. Okay, it will perform, this is 1, this is 2. Then this function perform 1 plus 2, which is 3. Okay, this value is propagated to its parent. Okay, next this function, this is the parent, this function, this will call this one. Okay, so this will call this one with the fib of 4. This is executed. Then this will call fib of 2. So it will reaches here. This also called but not executed. Then this is called fib of 0. Okay, fib of 0. What is fib of 0? 0. Okay, 0. This is returned back to here. Okay, this is returned back to here. Now it is 0. Then it will call this fib of 1. Fib of 1 is 1. Okay, you can just note the order and write it in the notebook. Okay, so now it is returned back 1. It will perform 0 plus 1. It is 1. Okay, it will perform 0 plus 1, then 1. Okay, then 1. Then what I will do? This will return. This will return 1 back to its parent. Okay, this will return 1 back to its parent. Then what? Then this will call. Then this is executed. Fib of 3 is executed. Then it will call fib of 1 and fib of 2. Okay, fib of 1 and fib of 2. Fib of 1 will return which value? It will return 1. Okay, so 1. Then it will call fib of 2. Fib of 2. Then what will happen? It will call fib of 0. Fib of 0. It will return 0. Okay, it will return 0. It will return 1. This will return 1. This will return 1. Okay, so 0 plus 1 is 1. This value is returned back. This will return 1 back here. Okay, so 1 and 1. 1 plus 1 is 2. This will return 2 back to here. This will return 2 back to here. Then 2 plus 1. 2 plus 1, it's 3. Then it will return 3 back to here. 2 plus 1 is 3. It will return 3 back to here. Okay. So in this way it will work. In this way it will work. 3. Then it will return the final value. Okay. This way and this will work. Anyway, this is the okay, this is the recursion tree. Then for getting the answer, how many calls are needed? One. How many nodes in the recursion tree? There are 13 nodes. Okay, you can observe here there are 15 nodes are there. Okay, if n equal to 5, there are 15 calls in this recursion tree. Okay, so if you analyze this algorithm, then you will get a big of 2 raised to n. So this is an exponential growth algorithm. Okay, so it will be one of the difficult algorithm if n becomes very large. So we want to find a good, more efficient algorithm. How can find it? So first we are focusing the disadvantage of this algorithm. That is, need to execute the overlapping subproblem. That is, what is overlapping subproblem? Overlapping subproblem. This is also very important. So overlapping subproblem means, for example, you can consider fib of 2 here. Okay, you can consider fib of 2 here. Fib of 2 will find a 0 plus 1. This is fib of 2. Okay, this part. This is fib of 2. Fib of 2 always returns 2. Okay, fib of 2 will return 1. Okay, there is a small mistake, I think. 0 plus 1 is 1. Actually, it will return 1 here. Then 1 plus 1, 2 will be returned to here. Okay, in this way it will work. Anyway, the problem is this is fib of 2. Okay, this is a sub problem. Here fib of 2 also coming. Okay, this is also fib of 2. Here also fib of 2 is coming. You can observe here fib of 2. This is a sub problem. Here also the same sub problem is coming. The same function need to execute. Here also, here, this also fib of 2, all producing the same result. So that is the problem of overlapping subproblem. That is, all subproblem create the same result. But we are executing all. Okay. In this case, we are executing all separately. So this is one of the disadvantage. So that is, need to execute overlapping subproblem. To solve this subproblem, dynamic programming based approach can be used. That is, the result of subproblem stored and reused. Memoization concept is applied. That is, instead of executing overlapping subproblem and finding solution again, we will use memoization. That is, the result of a subproblem is stored, then it is reused. So for example, suppose this is a subproblem for calculating fib of 2. I will store the result somewhere else. Then while solving this, in this situation, I will just reuse this variable. Okay, that is memoization. By applying the memoization, we can solve this problem. Okay, so that is divide and conquer with the memoization concept. Okay, divide and conquer with the memoization. That is divide and conquer with the memoization. So here you can note we are using an array F. Okay, we are using a global array F, and if n less than or equal to 1, we will store the value of n in that array. then return n. Okay, then we will check if f of n not equal to -1. If f of n not equal to -1, we will return f of n. Okay, this is additional, another code is added. Then if these are just this is the general case. Okay, then in the else part, what we will do, we will call this one, and the result is also stored in f of n. Then return f of n. In this way, we modified the divide and conquer approach problem. Okay. This problem is modified by introducing a storage f. Okay. So what is f? We can go to the f. What is meant by f is an array used to store intermediate result or Fibonacci number, that is, it is used for memoization. Okay, so basically initially f, the array f is initially with the -1 or null value. Okay, we can consider it as -1. Then what will happen? Just check the working of this algorithm. Okay, so here we want to find the fifth Fibonacci number. So we will call fib of 5. Then it will call this. Then it will call this as executed. Then fib of 3. Then it will call this fib of 1. We reached at the base case, fib of 1. What will happen? Fib of 1. Okay, this is the base case. Once we reach the base case, what we will do? 1 less than or equal to 1. So the value of n is stored in that position. That is f of 1 become 1. Okay, just note this code. In the once we reach the base case, we will store the value in the corresponding position. Okay, so you can note here in this array f, I stored this value. Okay, this value. Okay, then what I will do, as usual, I will return back the value. I will return back to this position. Okay. I returned back here. Okay. Okay, then what it will do, it will call this and fib of 2 is executed. Okay, then it will call fib of 0. This is executed. What will happen? Fib of 0. So this is updated. Okay, fib of 0. That is, after reaching base case, I will store the Fibonacci number in this position. Fib of 0 is 0. This is updated. Okay. Then I will return back here. Then I will call this one, fib of 1. Okay, this is a base case. So I will again updating this. This is already updated, but here I am one more time updating. No problem. So here I updated. Okay, then what will happen? Then it will return back to fib of 2. Okay, I will return back to fib of 2. From fib of 2, what will happen? We can go to that case. So fib of 2 is now this and this is added, then it is stored in there. Okay, so what will happen is that here you can note this position. Fib of 2 will update second position of f to 1. 0 plus 1 is performed. Okay, this is 0. This is 1. 0 plus 1 is 1. It is updated. This array is updated. Okay, now I am returning back here. After I return back, what will happen? From here I already returned back. From here also I returned back. Then what will happen? Fib of 3 is updated with 2. Okay, that is this position number 1 plus 1. Okay, 1 plus 1. 1 plus 1. It is 2. Okay, this is updated. Then I will go back here. Okay, then I will go back here. Then I execute this one. This is very important. Fib of 4 is called. Okay, after that, what will happen? Fib of, it will call fib of 2. Okay, this is very important. That is, it will call fib of 2. Okay, but it will not call any other functions. Okay, note that. Okay, that is, fib of 4 will call fib of 2. Then what will happen? We can go to the algorithm. It will check fib of 2 less than or equal to 1. Okay, then it is not correct. Then f of n, f of 2 not equal to minus 1. In this case, what is f of 2? In this case, f of 2 is 1. It is not equal to minus 1. So what will happen? It will return back. Okay, from here it will return back. It will not call any other functions from here. Okay, that is the use of memoization. That is, the fib of 2 result is stored in this position. Here it is stored. Okay, while calling in this situation, I will just use that result and I will return back. Okay, that is memoization concept. That is the use of memoization here. Okay, so I just returned back to here. Okay, then it will call fib of 3. Okay, it will call fib of 3. So what, I want to execute fib of 3, but what will happen? 3 less than or equal to, it will work in this way. It will first check 3 less than or equal to 1. No, then control reaches here. Then it will check if f of 3 not equal to minus 1 at this situation. At this situation, what is f of 3? At this situation, f of 3 is 2. It is not equal to minus 1. Then what I will do? I will return back. Okay, I will immediately return back to here. I will again return back here. I will not call other functions from here. Okay, so I will return back here. Then I will update this. Okay, fib of 4 is 3. Then I will go back to here. Okay, then I will go back here. Then I will update this one, fib of 5. Okay, in this way it will work. Okay, so what is the advantage here? These calls below this, we need several calls, but these are all eliminated. Okay, so as a result, you can observe here the total number of calls is reduced to 9. Okay, basically at first we need, if you are using divide and conquer approach, we need 15 calls. It is reduced to 9. Okay, then if you analyzed this method, then the complexity will be big of n. That is 2 raised to n is reduced to 2 raised to n is reduced to n. So by using memoization, okay, by using memoization and dynamic programming approach, this complexity, divide and conquer approach need 2 raised to n, but it is reduced to n. That is linear. Okay, exponential is reduced to linear. So that is the use of memoization and dynamic approach. Then another method. Okay, there is another method of dynamic programming approach. Dynamic programming approach means solving the problem and reusing it. Okay, so it is an iterative dynamic programming approach based algorithm. Okay, that uses memoization. Here we discussed recursive case, recursive dynamic programming approach with memoization. Here we are discussing iterative dynamic programming approach based algorithm for solving Fibonacci number. It is very simple. Fib of n, if n less than or equal to 1, return n. Then what we will do? We will store f of 0 equal to 0 and f of 1 equal to 1. Then we will initialize n. We will use this iterative loop. Okay, so it's very simple algorithm. Then at last we will return f of n. The working is very simple. It it is initialized in this way. F of 0 is 0, f of 1 is 1. Suppose I want to find the first Fibonacci number. Then what I will do? I will just return this. Okay, very simple. Suppose that is n less than or equal to 1 case. Okay, if n less than or equal to 1, I will just take the element and I will return from here. Okay, if n greater than or equal to 1, for example, suppose n is equal to 3. Okay, suppose n equal to 3. Okay, what will happen? So if n is equal to 3, it will just execute this code. This code is executed from I equal to 2 to 2 less than or equal to 3. Okay, so initially what will happen is that I equal to 2. Okay, so this is updated. When I equal to 2, fib of 2, f of 2 become 0 plus 1, 1. Okay, next I become 3. Then this is this plus this. Okay, this is updated. That is, this for loop is executed until I less than or equal to n. Okay, then we got the solution. That is, what is when n equal to 3? What is the fib of 3? Fib of 3 is 2. Then this is returned. Okay, this algorithm also uses the concept of memoization. Okay, we solve some problem, then we will reuse it in the future. Okay, so this is also a dynamic programming approach based algorithm. Okay, this is also a dynamic programming based algorithm. Okay, so next in the previous class we discussed chain matrix multiplication. That is, chain matrix multiplication is also a dynamic programming based algorithm that uses iteration. Okay, through the iteration there is no recursive function. We just used the iterative method. Okay, then we solved that problem. Then we are discussing Bellman Ford algorithm. So we already discussed it, so I'm not repeating much more, just I'm refreshing. What is Bellman Ford algorithm? What is the use of Bellman Ford algorithm? It is used to find the shortest path from a single source to all other vertices, but in addition it can find negative edged cycles, negative weight cycle. It can find a negative weight cycle. Okay, so here also we are using an iterative method. Okay, this Bellman Ford algorithm uses an iterative method. So in the first part there is an initialization. Okay, this already discussed, so I am not repeating, just go through it. This is initialization. Next is relax function. Okay, there is a relax function. Anyway, this is the initialization. Then for I equal to 1 to mod g dot v minus 1, what we will do? We will perform relaxation. Okay, so what is relaxation? What is relaxation means? This is the concept of relaxation. Okay, then after relaxation we will get a graph which contains the shortest distance. But after that what we will do? We will check for negative edged cycle. Okay, this is the code for that. After executing that we will get the final result. So this case we already discussed using 1 hour. Okay, please just use that and study. So this actually comes in the Bellman Ford algorithm actually comes in the 4th module. Okay, this is also a dynamic programming based algorithm. Okay, dynamic programming based approach. Okay, so and it uses iteration. Okay, so please study it. In the previous class I given some assignments. Okay, I will give some more questions based on some problems. Today I will give it to you. Okay, so this is about today's class. Okay, So next class we will start module 5. Okay, in the module 5 we want to study greedy approach. Okay, greedy approach to the problem solving. So in the fourth module we are studying different approaches. Okay, in the first fourth module we studied divide and conquer approach, then dynamic programming approach. Then in the fifth module we want to study greedy approach to problem solving. Okay, so these are the different approaches in the university exams. uh, Sometimes questions will be like this: differentiate between uh, divide and conquer approach, dynamic programming approach, or differentiate between dynamic programming approach, uh, other is greedy approach. In this way they may ask questions. So now we discussed the divide and conquer approach and dynamic programming approach. Okay, so the next class we can start greedy approach. Okay, greedy approach to the problem solving. Okay, okay. Please give your attendance in the chat box. Please give your attendance. One, Akash. Okay, Pinant. Next, Pinant. That's okay. Next. Ajmal, Agil Sipo. Ajmal absent ആണോ? അനക, അഞ്ജലി, അനുഗ്രഹ്, അതിനാണ്. അജ്മൽ ആബ്സെന്റ് ഇട്ടിട്ടുണ്ട്. ആബ്സെന്റ് ആണോ? ദേവിക. നെക്സ്റ്റ് ദിൽന. ദേവിക, ദിൽന. ഓക്കെ, ദിൽന. മസ്ന, ജസ്ന. ഓക്കെ, നെക്സ്റ്റ് നഫ, നേഹ, നിതിൻ ബാബു. കീർത്തന, കാർത്തിക്. കാർത്തിക് പ്രസന്റ് ആണോ? കാർത്തിക്, പ്രണവ്, പ്രണവ്സി, റൈസ, റസാന. 1 minute. റസാന. ഓക്കെ, ഓക്കെ. കാർത്തിക് ആബ്സെന്റ് ഇട്ടിട്ടുണ്ട്. ഓക്കെ, അജ്മൽ ഇപ്പോഴാണോ വന്നത്? ഓക്കെ, നെക്സ്റ്റ് കാർത്തിക് ആബ്സെന്റ് ആണ്. ഓക്കെ, ഓക്കെ. അജ്മൽ പ്രസന്റ് ഇട്ടിട്ടുണ്ട്. നെക്സ്റ്റ് റോഷൻ. റോഷൻ പ്രസന്റ് ആണോ? ഓക്കെ, സഹലബി. സഹലബി, സഹലായൻ. സഹലായൻ പ്രസന്റ് ആണോ? ഓക്കെ, നെക്സ്റ്റ് സംഗീത്, സാരംഗ്, ഷറുണ്, ശ്രദ്ധ. സാരംഗ്, ഷറുണ്, ശ്രദ്ധ. ഓക്കെ, വിഷ്ണു, വിനോദ്, ബേബി, ശ്രീഷ്മ. വൈഷ്ണവി, വിഷ്ണു, വിനോദ്. ഓക്കെ, ഓക്കെ. അഞ്ജിത, ഷിറോണ. നഫ. നഫ എപ്പോഴാണോ വന്നത്? ഓക്കെ, നഫ പ്രസന്റ്. കാർത്തിക് ആബ്സെന്റ് ഇട്ടിട്ടുണ്ട്. കാർത്തിക് പ്രസന്റ്. ഓ, നഫ പ്രസന്റ് അല്ലേ? ഓക്കെ, കാർത്തിക്. ഓക്കെ, കാർത്തിക് ആബ്സെന്റ് ഇട്ടിട്ടുണ്ട്. ഓക്കെ, എനിവേ നെക്സ്റ്റ് ക്ലാസ് ഗ്രേഡി അപ്രോച്ച് സ്റ്റാർട്ട് ചെയ്യും. ഓക്കെ, അപ്പോൾ സീരീസ് എക്സാമിന് ഇതുവരെയുള്ള ടോപ്പിക്സ് ആണ് ഉണ്ടാവുക. എല്ലാവരും നന്നായിട്ട് പഠിക്കുക. ഓക്കെ, താങ്ക് യു.